Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be discussing the problem, find the median of two sorted arrays. Now this is a lead code hard problem, yes. So you need to understand it really well in order to solve this. So what is the question stating? The question is stating that you'll be given a couple of arrays, yes. You'll be given a couple of arrays and those arrays will be sorted in itself. Like array 1 is sorted, array 2 is sorted. And you need to figure out the median. If you don't know median, it's a very simple thing. These are couple of arrays, right? Sorted. So you merge them and you get the other sorted array. So the other sorted array will look something like this. So once you've merged it into a sorted array, if you count the length will be n1 plus n2. That's 10, which is an even length. So if it's an even length, you simply take two middles because an even length will have two middles. So this is 4 and 6. So if you add them up, and you divide them by 2, you get something like 5. So that's your median. Basically take the couple of middles and take the average of them if the length is an even length. What if you have something like, let's say, 1 3, and over here you have something like 4 5 6. So these are the couple of arrays. So what you'll do is you'll again merge them into a single array. So that gives you 1 3 4 5 6. So if you have this, the length over here is a odd length, which is 5. So if there is an odd length, there will be only a single middle element, and that will be your median. So that's the definition of median. So if this question comes up in an interview, which is the first solution that you will propose to the interview? It should be the naive solution. What is the naive solution? Very simple. If you remember merge sort, there is a merge method that we write, right? Where we have two sorted arrays. Can we not use that over here? Let's have a pointer standing here. Let's have a pointer standing here. Whichever is the smaller, take it. That's one. Then move the pointer to the next. Now which is smaller, 2 or 3? 2. Take it. Move the pointer to the next. Now which is smaller, 3 or 3? Anyone you can take. Now which is smaller, 4 or 3? 3. Move the pointer. Now which is smaller, 4 or 6? 4. Correct? Take it. Move the pointer. Which is smaller, 6 or 7? 6. Take it. Now which is smaller, 7 or 15? 7. Take it. Move the pointer. Now which is smaller, 10 or 15? 10. Take it. Now which is smaller, 12 or 15? 12. Take it. Move the pointer. Now which is, you don't have anything to compare. So just copy paste 15. So you can definitely put this into some data structure, and whichever is the middle, like over here the length is even. So there will be a couple of middles. So just pick them up and divide them by 2 and you'll get your median. Very simple. Use a two-pointer approach and put them into some data structure and you get your answer. Time complexity, it's definitely BIGO of n1 plus n2, where n1 is the length of the first sorted list and n2 is the length of the second sorted list. The space complexity is again BIGO of n1 plus n2 because you are storing all the elements into some other data structure. So this will be a naive solution. Can you optimize this? Definitely yes. We can make this to BIGO of 1. How can we make that? Again, if you have a simple observation, we know one thing, that we actually require the fifth guy and the sixth guy. So when you are doing the comparisons and you're picking up 1, you're picking up 2, you're picking up 3, you're picking up 3, when you're doing the comparisons, why don't you maintain a counter? You simply maintain a counter. And whenever the counter picks up the fifth element, just store this somewhere. And whenever your counter picks up the sixth element, take that up and store it somewhere. So once you have got your fifth and sixth elements, just get an average of that and you will definitely get your median. So instead of storing in data structure, just use a counter and get only the desired elements, because you're not concerned with all the other elements. You're just concerned with 4 and 6. So why don't you do that, right? So if the length is odd, then you're just concerned with one element. So just pick it up. So this will be the better version of the naive solution, that is BIGO of 1. So this video is sponsored by Reliable, which is backed up by Unacademy. Now let me give you a short introduction about them. They're basically the first hiring tournament platform. Now what they've done is they've tied up with a lot of startups who are hiring freshers and people who are at the early stages of their career. Now they have around 500 plus positions across 50 companies, And now these companies are not Google, but at least these companies are like Razorpay, Upgrad, Urban Company, and many more. Like all the trending startups they have tied up with. So basically, you won't be requiring a college degree with a high grade score, or not a BTech degree or an MBA degree. If you have skills, you can definitely apply and participate in this given tournaments. Now, these tournaments will be specifically having a couple of rounds, the prelims and the mains, and I'll be leaving the entire detail about these rounds in a brochure below. You can check out the description. So basically, if you clear the mains, you will get mentoring sessions from the team, which will help you to clear the interviews. On the basis of the score that you get when you participate in the tournament, you can apply to the companies on their portal. Now, I think you should not miss this chance because jobs are very, very hard to come in this COVID era, and a lot of you do not have a good network, which often leads you to miss out on a lot of opportunities. Now, you must be thinking it will be costing a huge chunk of money, or it might be an ISA model. No, it will just cost you 1,999, and if you use the coupon code Take You Forward, it's gonna cost you 1,799. I think it's very cheap, and you should give it a try because even if you get an interview, and who knows, you might be able to crack a job. So if you are looking for an opportunity, I think you should give it a try. The last date for registration will be 22nd June, and the first tournament starts on 26th June. And if you want any other further details, I'll be leaving all the links up in the description. Go check it out, and yeah, do give it a try. Will the interviewer be happy with this? Obviously not, and he'll ask you to optimize it. So when you think of an optimized solution, you should take a notice that the arrays are sorted. And whenever these are sorted arrays, the first algorithm that should come to your mind should be binary search, definitely. So let's see if we can actually implicate binary search. So if I club these into a single sorted array, the elements will be something like this. Now the length is 10, correct? So can I say, if I draw a partition, I know one thing for sure, the left half will contain 5 elements. I know one thing for sure, the right half will contain 5 elements. Why don't I take this advantage and try to solve this problem? How is the question. Now just imagine for a simple stuff. If I say that I'm gonna pick 3 elements, or let's say I'm gonna pick 4 elements from the first array. So will I have 1, 3, 4, 7 for the first array? I have picked 4 elements from the first array. Now, how many elements does this left require? Can I say that it requires 5 elements? So, what should I pick up from array 2? A single element. So, just pick it up now. So, in this way, you can actually form your left half. Okay. Now, what will be the right half? The remaining elements. The remaining elements are 10, 12, and over here 3, 6, 15. So, I can actually pick up elements in this way. Now, can I also say, what if I decide to pick up something like 1, 3, 4, that is 3 elements from the first array. So how many elements can you pick from the second array? Definitely 2. So those 2 elements will be 2, 3. So the remaining elements will be forming the right half. So the right half will be 7, 10, 12, and over here it will be something like 6 and 15. I can also pick the 5 elements in this way. Now, can I also say, what if I decide to just pick couple of elements from array 1? Hence, I will be picking up 2, 3, 6 from the array 2 because I picked just couple of elements from array 1. So 3 elements have to be picked from array 2. And from here, I'll be picking like 4, 7, 10, 12, and a 15 from here. So I can also do this. So that will be my thought process. I'll try to pick up certain number of elements from the array 1, and I will try to pick up the remaining from array 2 in order to form the left half. Now, I just need to check if my picked left half is a valid one. Valid in the sense, is it the left half that I'm looking for? Okay, so how do I check that? Now, you can observe something. Whatever elements are over here are actually lesser than whatever elements are on the right half. I repeat, all the elements over here are lesser than all the elements that are on the right half. So in order to actually check if I've picked the correct one, I just need to check if all the elements here are lesser than all the elements on the right. How do you do that? Can I say one thing? These guys are smaller than these guys because it's the same array. 1, 3, 4, 7, 10, 12 are the same array. Can I also say 2 is smaller than 3, 6, 15? Again, same array, sorted. I just need to check if this guy is smaller than this guy and this guy is smaller than this guy. I just need to check this. Can I say if it is smaller, if it is a valid one, or if this is the left half, which is actually the answer, then the 7 has to be lesser than equal to 3 because all these elements are lesser than right. But I cannot see that. This 7 is greater than 3. I cannot see that. So this is not a valid one. Okay. Let's see if this is valid. Over here, what do you observe? 1, 3 is again smaller than this. No doubt in that. 2, 3, 6 is smaller than 50. No doubt in that. I just need to check the cross one. So let's check. Is 3 smaller than 15? Yes, it is. Yes, it is. Okay. But is this guy smaller than this? 6 is not smaller than 4. No, it is not. Hence, this is also not our left half because all the elements are not smaller than the right half. Perfect. Is this our left half or right half? Let's see. 4 smaller than 6? Yes. 3 smaller than 7? Yes. So can I say that all the elements on the left half are actually smaller than all the elements of right half? Yes, I can say. Hence, if I pick 3 elements from the array 1 and if I pick 2 elements from the array 2, I can actually form my left half and the remaining guys will form my right half. So this is how I can actually pick up elements. How to do binary search? I'll come to that. But this is how I can actually try to think of picking up elements. So once you have got this valid left half and you have got this valid right half, okay, how do you find the median? So let's assume I call this as left 1 because this is the left 1 and I call this as left 2, okay, and I will call this as a right 1 and I will call this as right 2. Can I say the median if the length is even? We will discuss about odd length afterwards. If the length is even, can I say this? This 4 is nothing but the maximum of the left half. Can I say this? Yes. Hence, can I say the maximum of length, the maximum of this left half is nothing but maximum of L1 comma L2? Definitely yes, I can say that. I can definitely say that. And what is the 6? Can I say it's a minimum of right half? Hence, I can say it's a minimum of R1 comma R2. Yes, it's a minimum of R1 and R2. And if I can get these two guys and if I divide them to find their average, can I say this is my median? Yes, this is my median. So I figured out how to find the median, how to check for validity. Validity check is very simple. This L1 has to be lesser than equal to R2. This L1 has to be lesser than equal to R2. And this L2 has to be lesser than equal to R1. The cross conditions have to be valid in order to, these cross conditions have to be valid in order to make sure that all the elements on the left half are smaller than all the elements of the right half, which will signify that the left half is the correct left half that you have picked. So this is the valid condition. This is the median condition for even length. I'll come to odd length. But how do you think of a binary search solution? Okay, let's understand that too. Now can I say in order to take 5 elements from the left, I can actually try a partition over here. That means saying I'm going to take 1 element. I can actually try a partition over here. That means I'm going to take 2 elements. I'm actually going to try a partition here. That means I'm going to take 3. A partition here. That means I'm going to take 4. A partition here. That means I'm going to take 5. Beyond this, it's not possible because I have to take only 5 elements on the left array. So how do you think of a binary search? Now you know one thing. You just need to decide where to do the partition. And if you can actually figure out that this is the portion where you need to do the partition, your job is moreover done. Okay, let's understand now. Now just imagine you are doing a partition over here, right? That means over here you've done a partition. Just imagine. Now you know this is not a valid one. How did you know that this is not a valid one? Because this 7 should have been lesser than 3. This 7 should have been lesser than 3. Perfect. But it was not. So in order to in order for the 7 to be lesser than 3, I need to reduce 3. I need to reduce 3 and I need to increase 3. Can I say this? If I do this, I can actually form a correct partition. So in order to reduce 7, if this is a sorted guy, because this is array 1, it's a sorted guy, you need to move left. Because the moment you move left, what happens? See, the 7 will go on the right, correct? And if you move left, you are only taking 3 elements. So you will have to take this 3 on the right. So you have 2, 3. Now, when you compare, you will have a 4. So you've reduced 7 to 4. You understand? You've reduced 7 to 4. And over here, you have increased 3 to 6. Just because you shifted the partition leftwards. So I hope you have understood when to shift the partition leftwards. But when do you shift it rightwards? Now imagine you had 3. This 3 is lesser than equal to 50. But what did not obey your condition? This 6 should have been ideally lesser than equal to 4. But that's not the case. Hence it is not satisfying. So in order to satisfy, what do you need to do? You need to reduce 6. Yes. And you need to increase this 4. So how will you increase this 4? Can I say, or how will you reduce this 6? Can I say, if this guy goes right, hence you will take more elements. And if you take more elements, this 6 will cut off, which happened in this case. And this 6 will reduce to something like 3. Hence, I have understood if a condition like this happens, I need to move right, or if a condition like this happens, I need to move left. So once you have figured out whether to move right or whether to move left, can you actually place your partition according to that? And you can actually try out all the partitions using a binary search method. And once you have figured out your correct partition, I think your answer is done. Yes, your answer is done. So let's take this example and do a dry run of binary search. So what you can see is I have these couple of arrays that are sorted. Again, 10 elements. So 5 will be on the left and 5 will be on the right. So I know I can pick a minimum of 0 elements from array 1 and a maximum of all the elements, that is 4 from the array 1. So let's assume low to be 0, high to be 4, saying that this is the minimum elements that I can pick and this is the maximum elements that I can pick. Now figure out the middle and let's call it something like cut 1. Okay, that means the number of elements that you're picking up from your array 1. So the middle is 0 plus 4 by 2, which is nothing but 2. So I'm picking up 2 elements, which means a cut over here, cut on the first array. What about cut 2? How many elements am I picking up from the second? Can I say if the total is 5, I'm actually picking 5 minus 2, that's a 3 elements from the array 2. I can. So the cut 2 will go over here, saying I'm picking up 3 elements from array 2. Perfect, the cuts are perfect. Now, can I say L1 is what matters? So I have a 12 as L1, I have a 3 as L2, I have a 14 as R1, I have a 4 as R2. I know, there are numbers like 7, 12, there are 1, 2, 3, 14, 15, and then 4, 9, 11. But what matters to us is these guys. Yes, these guys. And I just need to compare if this 12 is lesser than equal to this 4. I just need to compare that. And I see that it is not. Hence, this is not a valid partition. Now, I just need to decide where to move. I can see that this 12 has to be lesser than 4 in order to this be a valid partition. So I need to reduce 12. And how can I reduce that? Definitely I have to move left. Definitely. So if I have to move left, that's a binary search. And whenever I move left, what do? I do this in binary search, right? High equal to mid minus 1. So why don't you do that? So high will go 1 lesser from mid, which is 2. So that will become 1. So you go 1 lesser. So currently your low is at 0, high is at 1. So if you try to figure out which is the cut 1, what is the value or the middle? 0 plus 1 by 2. How much is that? 0. So what you're saying is, this is where you're putting the cut. Hence you're saying you're taking no elements from array 1. Perfect. Where will you put a cut 2? The cut 2 will obviously be 5 minus 0 equal to 5 elements is what you're picking from array 2. So that means a cut over here, you're saying you're picking up 5 elements from array 2. Perfect. So again, what matters to you is L1. So that's basically no elements from the array 1. And over here, 1, 2, 3, 4, 9 from array 2. And on the right half, it's 7, 12, 14, 15, and over here 11. Now if you're picking up no elements, always make sure you assign L1 to be a minimal value because you haven't picked up anything, right? So just make sure you assign it to int mean. This will be your L2, this will be your R1 again, and this will be your R2. So you just need to compare if this is the valid left half and valid right half. So this int mean is lesser than this 11. Perfect. These guys are lesser. But is this 9 lesser than or equal to 7? I see it is not. So what you need to do is, you need to decrease 9 and you need to increase 7. And how is that going to happen? So how are we going to increase 7? Very simple. You have to take this 7 from the right and you have to put it onto the left, which means adding up elements on the left, picking more elements. As of now, you're picking no one. So the low will move to mid plus 1 because you want to pick more elements. So the low moves to mid plus 1. What is mid? 0. Moves to mid plus 1. Goes to 1. Perfect. So currently low is at 1, high is at 1. Let's figure out which is cut 1. Cut 1 is 1 plus 1 by 2. That's 1. What is cut 2? 5 minus 1. That's a 4. So you're saying I'm going to pick 1 element from the array 1 and 4 elements from array 2. That's the orange stick. Okay, so let's try to pick up. So that's a 7. That's a 1, 2, 3, 4. On the right, that's a 12, 14, 15. And over here, it's a 9 and a 11. Perfect. Is this a valid one? Yes, it is. Why? 7 is lesser than 9 and 4 is lesser than 12. So I can definitely say this is a valid one. And if this is a valid one, can I stop over here? Yes, I can. And how do you find the median? Very simple. You add a 7, you add a 4. So you need to take the maximum on the left. So it's a 7 on the left. You add a 12, you add a 9. You take the minimum. So it's a 9. So the average of them is 8. And that is what your median is. So in this way, you can definitely find your median. So just remember one thing. Since you just require L1, L2, R1, R2 in order to compare if they are valid or not. So we always have couple of things. That is the cut 1 and cut 2. So if you carefully observe, if cut 2, this is the blue line, cut 2 was at the second partition. I was always taking the first index guy as my L1. So can I say L1 is nothing but array of 1 cut 1 minus 1. Can I say this? Yes. What was L2? L2 was always 1 before cut 2. So I can say L2 is nothing but array 2 and cut 2 minus 1. And similarly, can I say R1 is this guy 14, 2, 2. So it's a array 1 cut 1. This is array 2 cut 2. Simple. Just make sure of one thing. If there is like cut 1, you're not picking up any elements, so there will be no L1. In that case, make sure you take it as a minimal value. int mean or something like that. And also in L2, same thing. If you're not taking anything from the array 2, make sure you assign it to int mean. For R1, please make sure if there is no one on the right, you need to take a maximum, because R1 is always the greater guy. Similarly, R2, these guys has to be. This is what you do if there are no R1 and R2. Please make sure you check this edge case, because this is a very, very important edge case which people miss out. Okay, so you can look at the right portion, and that is what we generally do for even length, right? If n1 plus n2 is even. So let's take this example where I've added this 16 into this array 1. So now the length, or n1 plus n2, has actually become 11. Now let's do a very simple thing. Try to divide this into couple of halves, where you say that the left half is 6 and the right half is having 5 elements. So once you know how many elements are in the left half, can't you figure out the partition? And if you have figured out the partition, can't you check for its validity? You can. The only difference is you need to figure the 6 out. How will you do that? So if n1 plus n2, ideally this length is 5, ideally this length is 6. So 6 plus 5 would have been 11. So just do a plus 1 and a by 2. So what you'll get is 6. So once you have this length 6 of left half, I think the problem becomes super simple, right? The only difference is, in the even length, you always took 2 guys. That is the formula that you applied in order to find median. Over here, you know the median will always be the last guy of your left half. So can I say over here, the formula will boil down for median to be the max of L1 and L2, whatever is your left partition, you just take the last guy, and that will be your median. Yes, that will be your median. And for finding out the length of the left half, this is n1 plus n2 plus 1. You can also use this over here, the length of left half. Why? Because even if you take 10, which is the length, and you do a plus 1 and a by 2, then also you get a 5. And if you take something like 11 plus 1 by 2, then you get a 6. So this formula is going to work for odd as well as even. You just need to alter the median, and everything else will stay the exact same. Now till now, I hope you have understood the entire intuition as well as the algorithm. Now it's time to discuss the C++ code. Now the Java code is exactly similar. It's exactly identical. So you can definitely follow this and you can write your own Java code. I'll also be leaving the Java code link in the description. So you're basically given a couple of arrays, nums1 and nums2. Now, as I always said you, try to try to do binary search for the smaller size array. So if nums2 is smaller, make it nums1. So again, you call the function with nums2, nums1, so that you have the smaller size array ready, correct? Next, figure out n1, n2. Done. Now you know at minimum you can choose 0 elements, at maximum you can choose n1 elements. Simple. Just do the binary search, low lesser than equal to high, and try to figure out cut1. That's basically the middle. What is cut1? Low plus high by 2, correct? That is what cut1 is. Done. Next, try to figure out cut2. What is cut2? If it was even, it is n1 plus n2 minus cut1. Basically, the total, the half's length minus whatever you have taken from array 1, correct? So this works for odd as well as even. Done. Now, if you remember, L1 was this, L2 was this, R1 and R2 was this. So this is what I've written over here. Simple. I've taken these guys, and I've just made sure if I'm not taking anything from the left or the first array, I'm making it int mean. Similarly, if I'm not taking anything from the array 2, I'm making it int mean. Similarly, if I'm taking all the elements from array 1, so there'll be no right, int max and int max. So I made sure that I've covered up the edge cases. Now, what is the condition to check if it is a valid or not? You remember, if this one was L1 and this was one L2, this was what R2, R1, R2. You always checked L1 and R2. So this is what I've done, L1 and R2, left and right. And you always check left 2 and right 2. So that is what I've done. So if these conditions are valid, I can say whatever currently I have, like whatever cut1 and cut2 is currently, that's a valid one. And I check if the length is even. If the length is even, you remember this was the formula that you implicated. Simply implicate this formula and return the median. Done. If the length was odd, you always implicated this formula. So max of left 1 and left 2, correct? Now what if this is not a valid one? Now you remember this L1 has to be lesser than equal to R2. You know this? But this is not. This is not. If it is not, then can I say I have to actually reduce it if it is not? And if I have to reduce it, can I say I have to move my high to the left, that is mid -1? Or else, if that's not the case, I'm only left with one other case, that is moving the low to mid +1. I move it. And once I've done this, I should definitely get a valid partition. Okay. And just in case I don't get, that means the nums1 and nums2 were not sorted, and you can return something like 0.0. But this case will not come because the question clearly stated you will be given two sorted arrays. You just have to write a return statement, otherwise this function will not execute because it returns a double. Median can be double, right? So if, because this return statement is inside a if and a while loop, so you never know will this be executed or not. The program never knows, so you have to write an external return stuff in order to execute this code. So this will be the code. Now if I ask you the time complexity, can you tell me what will be the time complexity? Now, since you're always making sure over here that you're always doing the binary search on the minimal guy, so can I say it's a log base 2, whichever is the minimal length, n1 or n2? Because I'm always making sure that I do the binary search on that. Space complexity, am I using some extra space? No, that's a big of one. So that will be the time complexity as well as the space complexity. So guys, I hope you have understood the entire explanation. Just in case you did, please make sure you like this video, and if you're new to our channel, do check out our channel. You'll feel like subscribing. Okay, so with this, let's wrap up. Bye bye.
Whenever your heart is broken.